Assalamualaikum and hi. Today we will learn about descriptive data. So in this chapter we will cover 5 subtopics. There are the first one introduction and definition. Second one will be qualitative and quantitative data. The third one will be frequency distribution for group data. And the fourth one will be measures of central location and also measures of dispersion. And the last one will be box and whisker plot shapes of distributions. So, as an introduction, these are mathematics marks for 30 students who are taking mid-semester tests. So, all you can see, there are 30 marks. So, how can we interpret these marks and how can we explain it to others? So, the answer is by using statistics. Okay. So, what is statistics? Statistics is a science that deal with collecting, organizing, summarizing, presenting, and analyzing the data. So there are two types of statistics. The first one will be descriptive statistics, and the second one is inferential statistics. So what is descriptive statistics? Okay, descriptive statistics is collecting, tabulating, presenting, and summarizing information in clear and effective ways in order to describe the set of data. And inferential statistics involve the techniques of analyzing sample result to draw conclusion about the population. So we can see that descriptive means you'd have to describe what the data is all about, and while the inferential statistic is you are making conclusion about the population. So these are the very basic definition of statistics. Okay, there are some application of statistics. We can use statistics in sciences, physics, chemistry, biology, and as well as mathematics. Okay, and we can also use statistics in business, engineering, medicine, economic, and social planning, as well as in education. So these are all the application of statistics. So, okay, I have mentioned about population just now, ataupun populasi. So, what is population? Okay, a population is the entire or the complete collection of data whose properties are analyzed, meaning that population adalah keseluruhan satu kumpulan yang besar. It contains all the subject of interest. Okay, a population can be of any size. Boleh jadi size yang besar ataupun sederhana ataupun yang kecil. Its item needs to be uniform but must share at least one measurable feature. Okay, okay. While when you have population, you will also have sample. So a sample is any set of entities, cases, subjects, item, or experimental units chosen from the population, which means that sample is a bit smaller than population, or we can say that sample is actually a subset of the population. Sample tu kecil sikit daripada populasi. Okay, here is the example. This is a population of all students from PPST in UMS. So we have sample 1. Okay, kita punya populasi adalah semua student PPST. Okay, then in that population, we have a few samples, 4 samples. The first sample will be girls with spectacles, girl yang berkaca mata. And the second sample will be girls with hijab, pakai tudung. The third sample will be boys with spectacles. And the fourth one will be girls from Melaka. So we have a specific for each sample, there are the specific characteristic. Okay, so when we draw our what we call this a Venn diagram, kita draw Venn diagram, ada few sample yang overlap, bertindih dekat situ. Yang mana sample 1, sample 2, and also sample 4. So why can from here what you can see is that sample 1, 2, 3, 1, 2, and 4 is actually overlap because there are actually girls. The sample involve girls. Okay, so you can see that the Venn diagram is overlapping. While sample 3, it is outside. Dia tidak bercampur because sample 3 involve only boys. Okay, so this is how you draw your Venn diagram. So this is what does it mean by population and also sample. Okay, next is qualitative and quantitative data. So we are moving on the second subtopic, qualitative and quantitative data. But before that, you need to know what is a variable. A variable ataupun dalam bahasa Melayu adalah pemboleh ubah. A variable is any measured characteristic that differs for different subject. For example, if the weight of 30 subject were measured, then weight would be a variable. Variable tu pemboleh ubah lah. Contoh, berat, weight, height, tinggi, apa lagi? Colors. So that are all we can call it as variable. Okay, so in variable, there are quantitative data and also qualitative data. Quantitative meaning you can count. Qualitative mean you cannot count. You cannot be numerically measured. So for quantitative data, observation of variable that can be numerically measured. Boleh diukur. Okay? Numerically measured. So bila kita kata benda tu boleh diukur, it's either continuous or discrete. Sama ada dia bersambung ataupun discrete. But for qualitative data, kita ada dua jenis data, kualitatif dan juga kuantitatif. And for this one, qualitative meaning that you cannot measure it numerically. Kita tidak boleh count dia secara nombor. What we can do is we classify it into categories. Since kita tidak boleh measure, ukur dia, kita cuma boleh kategorikan dia atau kelaskan dia. So there are two types of data, quantitative and qualitative. Okay, variables can be quantitative or qualitative. Sama jugalah kalau data tadi boleh jadi quantitative data ataupun qualitative. Variables also can be quantitative or qualitative. So a quantitative variables are measured on an ordinal, interval or ratio scale. Maksudnya dekat situ, pemboleh ubah yang kuantitatif, kita boleh measure secara ordinal. Ordinal mean order. Dia ada susunan dia, ranking. Okay? Ordinal, order. Kalau interval meaning dia ada range dia. Okay, contoh dari 1 ke 10, 11 ke 20, that one is interval. And ratio 1:2, 2:4, macam tu. Okay. For qualitative variables are sometimes called as categorical variables. So for qualitative, it cannot be measured. So what we can do just now, I said we can only categorize them. Okay, so we can categorize them and it will be measured on nominal scale. So ada beza. Ordinal is you susun dia ikut order, dari kecil ke besar atau besar ke kecil. But for nominal is nominal is different. It's not like ordinal. Okay, nominal means dia ada nama-nama dia. Okay, for example, blood types. Blood types, you have blood type A, B, O. That one you cannot rank kan? You tidak boleh susun order. That one is by name. So that one is considered as nominal. Macam colors. Colors, we have blue, yellow, green, red. That one is also nominal. Okay, let's see the example over here. If 5-year-old children were asked to name their favorite color, then the variable would be qualitative. Sebab colors we cannot measure. Colors we can only categorize them. Kita cuma boleh kategorikan dia. So that one will be qualitative. Okay, the second one. If the time it took them to respond were measured, masa yang kita ambil masa yang kita record untuk kanak-kanak tadi bagi respon derang. So that one will be masa, meaning that kita boleh count kan, kita boleh ukur. That one will be quantitative. So I hope you are clear about these two, quantitative, what is quantitative, what is qualitative variables. Okay, let's say about this one. Just now you have quantitative and also qualitative. Remember that for quantitative, yang boleh dikira atau that one, we have either discrete data or also continuous data. Yang ni masih dalam quantitative. For discrete data is a data that assume countable value. Discrete meaning that you can count it one by one. For example, number of student in a class. Kita ada, let's say we have 26 of student or 45 of students. That one you can count 1, 2, 3 up until 26. Okay, second one, the number of cars sold on any day at a car dealership. That one also you can count how many cars there are being that have been sold. And then the third one will be number of person in a family. Berapa orang dalam your family? Also that one you can count. Okay, that are all discrete data. Discrete mean you can count. But for continuous data is a data that assume any numerical value over a certain interval. Meaning that for continuous data you involve interval, ada selang dekat situ. Interval means selang ataupun range. For example, the weight of student in a class, berat student. Kalau berat student usually kita akan letak dalam bentuk range or interval. For example, 40 kg to 50 kg, 60 to 70 kilos. That one is continuous. Anything that involve interval ataupun range or selang, that one will be continuous data. The one that you can count straight away directly is discrete data. Okay. Okay, next, the time taken to complete an examination. Masa yang diambil untuk complete examination. Some of them can answer 1 hour. Some will be 1 hour and a half. Okay, yang tu dah ada interval. And the amount of soda in 150 ml can also, that one can also be interval. So these are all the continuous data. Okay. Next, when you have discrete and continuous data, you will also have group and ungroup data. Data yang terkumpul dan juga data yang tidak terkumpul. Ungroup meaning tidak terkumpul and group is data terkumpul. So raw data can be represented in ungroup data and also group data. Group data is group in interval. So apa beza antara dua ni? Yang terkumpul dan tidak terkumpul adalah data yang terkumpul ataupun group data, kita tulis atau kita present dia dalam bentuk interval ataupun selang. For example, this one is example for ungroup data. So the way you write it down is like this, using comma, 3, 5, 6, 7, 2, 3, 5, 6, 2, 5, 2, 4, 6, 5. They are all using commas. This is raw data. Maksudnya data mentah lah. Okay, yang ni. And then the second way you can write it down is using table like this. For example, number of children. There are 0 children in the family. So the frequency is 3. Ada 1 children dalam that family. Okay, so ada 7 family yang ada satu orang anak. And then ada 4 family yang ada 2 orang anak. So this is either you can write it down using this one, the first one, or using table. This is ungroup data. But for group data, remember for group data, we write it down using interval. Di dalam bentuk selang macam ni. So anything written down in interval, ada selang or range like this, will be known as group data. For example, height, ketinggian, we measure it from 150 to 155. 105 to 160, 160 to 165, 165 to 170. So each of these interval, they have their own frequency. For 150 to 155, you have 2%. Okay, then for the next one, you have 8. For the next one, you have 6, and the last one, you have 5. So this is all group data. Okay, so the only difference, you can see this is almost similar because they are using table, but the difference is that for group data you have interval, ada selang dekat situ, ada dash dash dash, that one. Okay, so that one will be your group data. Yang ni tidak ada selang. Okay, they're just single number. So that is group, and other one is ungroup, and this is group data. Okay, we move on to the third subtopic, which is frequency distribution, taburan kekerapan. I'm sure you have learned this before during your SPM. Just recall it again. So, for example, you have ungrouped data over here. This is, remember, ungrouped data, we written it down using commas. So, what is the middle value of the set? Apa titik, apa nilai tengah-tengah untuk set ni? What is the average? So, how do you going to interpret all of this? So, to help us interpret the data, we need to know first the important term in the construction of frequency table. So, when you are given ungrouped data macam ni, untuk senang, so that you can see or you can analyze the data easier, you have to construct a frequency table ataupun jadual kekerapan. So in frequency table, you will have to know what is your class interval, class limit, class boundary, class width, and also class mark. So 1, 2, 3, 4, 5. You have to memorize these 5 terms over here. Class interval, class limit, class boundary, class width, and also class mark. So how to construct a frequency table? So from this ungrouped data, there are actually many questions can rise from the from this data. So you have to know how to construct a frequency table, how to construct the histogram and frequency polygon, how to construct a less than cumulative frequency distribution table, or how to draw and or give from the less than cumulative frequency distribution table. So there are quite a few terms, new terms for you over here. So we will see this one by one. Okay, so this one is for group data. This is actually for ungroup, and you want to make it group data. So you will have frequency distribution, taburan kekerapan. So a summary, what is frequency distribution? Taburan kekerapan is actually a summary of how often each score occurs by grouping scores together in a tabular arrangement. So in a tabular arrangement, meaning that you have to construct your frequency distribution table lah, of data by classes with the corresponding class frequency. Okay, yang panjang-panjang ni maksud dia taburan kekerapan tu maksud dia you group kan, you kumpulkan data-data tadi tu, yang ungroup data tadi, based on dia punya scores. Based on dia punya score. So you akan create a few interval class dekat situ. Interval class, for example, previously you have like this kan, you ada 56, 88, 94. Okay, so we can say we have the smallest one is 49. You can start with, maybe you can start with 40 until 50, then 51 until 60. So that one is what we call as class interval. Dia ada set, dia ada class. Okay, so class interval. Interval means that interval that includes all the values in qualitative data set bounded by the lower and upper limits of the class. So dia ada, kalau class interval ni, bila kita buat kita punya class interval, maksudnya kamu ada lower limit yang paling bawah, dan juga upper limit. Nanti kita akan tengok apa tu lower limit and upper limit. Okay. And the number of class interval usually denoted by K. Ni, small letter K. So how you going to find this K? We have a formula or that are using Studge rule. Okay, dia ada formula ni. K equal to 1 plus 3.3 log base 10 n. So this is the formula how you going to find your K. What is K? K is actually number of class intervals. So, untuk tentukan berapa banyak class interval yang kamu kena buat, you have to use this formula. So, what is N? Small letter N here is the total number of observation in the data. So, for example, here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10, so you have 20. You have 20 data. Okay, ada 20 data dekat dalam ni. So, to construct your frequency table, you have to determine your class interval first. So, from how to determine your class interval? Using this K. Okay, just plug in the value 1 plus 3.3 log n, your n is 20. So nanti you akan dapatlah value untuk you punya K. So that is how you know berapa banyak kelas you kena buat. And then you have class boundary. So walaupun nama dia lebih kurang sama, but the way how you going to calculate it is different. So for example, class interval, you have this formula. Class boundary ada lagi formula dia. So you're using midpoint of class boundary mean midpoint titik tengah of upper limit of one class and the lower limit of the next class. Okay, for class width or class breadth, the formula is upper boundary minus lower boundary. And the last one is class mark, or we known as midpoint. This is the formula, lower limit plus upper limit, then we divide by 2. Okay, let's see. This is what we call as frequency distribution table. Inilah dia. So what is class interval? Selang kelas tadi tu, this is selang kelas 2 to 4, 5 to 7, 8 to 10, 11 to 13, 14 to 16. This is actually the class interval. So how do I know my class interval consists of 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 class interval is I'm using this formula. So nanti kalau I dapat K equal to 5, which means that you have 5 kelas. 5 kelas macam ni. And frequency meaning that how often each score occurs, kekerapan. Berapa kerap score tu berulang. Berapa kerap score tu terjadi. This is lower limit and upper limit. So ada beza lower limit and upper limit. Lower limit means over here you have class interval. The lower limit is 2. Upper limit is 4. So sama juga untuk yang ni. Lower limit 5. Upper limit is 7. But for boundary, jangan confuse between limit and boundary. For limit, you can you can take straight away from here, your class interval. But for boundary, you have to plus or minus 0.5. For example, you have lower boundary over here. Your class interval start with 2, meaning that your lower boundary 2 minus 0.5. That's why you get 1.5 over here. Okay, and the upper boundary is 4 plus 4.5. 4 plus 0.5. That you will get 4.5. And it's got the same for this one. Okay, you have your class interval or your class limit is 5, meaning that your lower boundary will be 4.5, upper boundary will be 7.5. Dia tambah tolak 0.5 saja for boundary. Okay, and the class width atau lebar kelas ataupun kelas breadth tadi kita kata the formula is upper boundary minus lower boundary. So you have your upper boundary 4.5 minus 1.5, so you get 3. Okay, class width ni dia kena sama semua. So apa maksud dia 3 dekat sini? 3 mean you have 2. You tengok you punya kelas. Class width maksud dia lebar kelas. So, you punya class interval consists of number 2 until 4. So, 2, you have 2, 3, and 4. That are 3 numbers. That's why you get 3 over here. 3, 3, 3, 3, 3. Sama juga, 5 to 7. Dalam 5 to 7 ni kita ada 5, 6, and 7. Ada 3. That's why you get 3 over here. So, class width, dia wajib sama untuk semua ni. Untuk semua kelas. And for class mark, this is the formula, midpoint. Class mark ataupun kita panggil sebagai midpoint, titik tengah. Lower limit plus upper limit, we divide by 2. So, you just pick your lower limit, upper limit, plus it, and then you divide by 2. So, you get the class mark. Okay? So, this is how you obtain your frequency distribution table. Okay? So, general method. So, these are general method in constructing your frequency distribution table. First, you need to decide the number of classes. How you're going to decide is using the starch rule, the formula K just now. The second step, sebab, of course, this will be the first step because first column tu adalah class interval. Without your class interval, you cannot count your lower limit and boundary so on ni. You kena find this class interval first. The second step will be find the value of range. Range tu macam mana kita cari range? Biggest value minus smallest value. And the third one will be find the class width. Apa tu class width tadi? Class width adalah range divided by number of classes. So ada dua cara. Satu macam ni, you guna upper boundary minus lower boundary, or the other one is using this formula. So ada dua cara untuk cari class width. And then step 4, set the class limit for each class. Okay, it is chosen such that there is no overlapping between classes and each value can go to only one class. Kenapa kita kena set class limit? Class limit yang ni. Lower limit, upper limit. Supaya tidak berlaku overlapping. Maksudnya, dekat sini you start with 2 until 4. Dekat sini you cannot start with 4 pula. You have to find other numbers so that they cannot be overlap. So, from here you start from 2 until 4. So, for the new class, you have to start with a new number, which is 5 to 7. And then here you start again with new numbers, which is 8. Okay, so make sure each class ni tidak ada yang bertindih nombor dia. No overlapping. So basically there are 4 steps in constructing your frequency distribution table. Okay, let's see again example. So we have berapa banyak number dekat sini? 1, 2, 3, 4, 5. Okay, we have 20 data. So from this data, you need to, the first step is you going to find or decide your number of classes. Okay, over here. So using the starch rule, you just plug in the value. What is your n? N mean your number of data. So dalam ni saya ada 20 data. So you just letak 20 dekat sini. So key in the value into your calculator, you get 5.293. So even though the answer is in decimal point, in decimals kan, dalam bentuk perpuluhan, so kita bundarkan dia. So 5.2 maksud dia lebih daripada 5. So the nearest kita ambil 6. Jangan ambil 5. You ambil yang lebih sikit. So you always take bigger numbers, not the less one. 5.2, you take 6. Okay, so meaning that you have to create 6 classes. Ada 6 kelas. Okay, so the next step is find the value of range. Range tu apa tadi? Range tu biggest value minus smallest value. Apa yang paling besar? Nombor paling besar dekat sini. The maximum is 94. The smallest is 49. So the range will be 45. So why do I need to find range over here? It's because in the third step, I will need the range value to calculate my class width. Okay, the class width, this is the formula, range over K. So previously we have found our K and also our range. So now you can find your class width, which is 7.5. So again, kita ambil nombor yang lebih besar. Instead of you taken 7, you take 8. Okay, so this is your class width, lebar kelas. Apa maksud 8? Maksudnya dalam satu nombor tu, dalam satu kelas tu ada 8 nombor. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so your class start from 1 until 8, for example. Okay, step 4, the last step. State the class limit for each class. Class limit. Apa tu class limit? Okay, class limit yang ni lah. This is class limit 49 until 56. You tentukan dia start dari mana sampai mana. So dekat sini the smallest is 49. So we will start with 49. Since kita kata kita punya class width tadi 8, kita punya lebar kelas tu ada 8, maksudnya ada 8 nombor. Start from 49, you kira lah 8 nombor. 49, 50, 51, 52, 53, 54, 55, 56. So daripada 49 ni until 56 ni ada 8 nombor. Itu maksud dia class width. Okay, then you repeat the same procedure again for the next class. Since dekat sini you dah stop with 56, you start with a new number which is 57. Okay, count again 57 sampai nombor yang ke-8 which is 64. Then stop until 64. So 57 until 64 ni ada 8 nombor dalam dia. Sama juga untuk yang seterusnya. That is your class limit. Okay. And then you have class boundary. Apa maksud class boundary tadi? Class boundary adalah you plus or minus 0.5 from your limit. Dekat sini you have 49. So 49 minus 0.5. You have 48.5. Untuk upper limit, 56 plus 0.5. So you get 56.5. Okay. That is class boundary. Boundary ni ingat, kalau boundary je dia kena tambah atau tolak 0.5. Okay. Then for class mark atau kita panggil titik tengah, midpoint, ni formula dia. Lower limit plus upper limit divide by 2. So what is your lower limit? Your lower limit is 49. Upper limit is 56. Tambahlah dua-dua ni and then you divide by 2 so that you get this value. Okay. And the frequency is 4. How do I get this 4? You count lah dari dekat sini. Dari 49 until 56. 49 until 56. Ada berapa dekat situ? So you have 4. Okay? Ada 4 nombor. And then dari 57 until 64. Ada berapa dekat sini? So you have 4. Okay? So you count it until here, from here. Then you total up this one, this frequency. Bila you total this one, you should get 20. Keseluruhan dia adalah 20. Sebab jumlah frekuensi mesti sama dengan you punya n of data. So you tambah 4, 4, 4, 1, 4, 4, 4, 1, 4, 4, 3, you will get 20. So make sure your total of your frequency is equal to your n. So this is your frequency distribution table. This is how you obtain it based on the 4 steps just now. Okay, so after you finish obtaining your frequency distribution table, now you can obtain your histogram. So what is histogram? So this is actually how histogram look like. It looks like bar charts. Okay, dia macam ni. Petak-petak 4 segi. Macam bar charts lah. That is histogram. Okay, for example, the waiting time for 50 patients. So your N will be 50 who are seeking treatment from a doctor in our clinic is shown in the following frequency distribution table. So, okay, frequency distribution table, yes. So dia punya ni dia dah given dalam table ni lah. So you need to draw a histogram to represent the above information. So dia dah bagi table, but you need to find the histogram. So how are we going to find the histogram? Based on the table. Ini table yang dia bagi. First, you need to find your class boundaries. You kena cari class boundary. And also your class width. Tengok daripada sini, you have 5 until 9. This is your limit. This is your lower limit. This is your upper limit. Lower limit, upper limit. So, daripada lower limit and upper limit, you can find your boundaries. So, your boundaries will be 4.5. This one, it will be 9.5. Okay. Ni sama jugalah. Kalau kita tolak 0.5, dia akan jadi 9.5 kan? Then, this one 14.5. This one akan jadi 19.5. 24.5 and so on. Dia jadi macam ni lah bila you bila you write it down without using the table. So daripada 4.5 to 9.5 itu adalah class width. Macam mana cari class width? Guna ni formula. Upper boundary minus lower boundary. So 9.5 minus 4.5 you get 5555. Class width tu usually dia memang sama. Okay, it's all the same for all classes. Because class width of all classes are the same, frequency can be used to represent the height of the rectangles. Dia kata dekat sini, since kamu punya class width, lebar kelas kamu tu semua sama, so kita boleh guna frequency untuk represent dia punya, untuk draw your histogram. So this is your F. Number of fashion is actually your frequency. This is going to be your frequency. This is your class limit. So from here, you can draw your histogram. Histogram dia guna class boundaries. Your x-axis is going to be the class boundaries. Dia punya x-axis. So, class boundaries yang kita cari tadi ni lah. 4.5, 9.5. Semua ada 0.5 because boundaries. Okay. So, 4.5 until 9.5, you have 3. And then, 9.5 until 14.5, you get 2. Over here ni. Let me jot down a bit. Okay, this one is 3. This one is 2. This is this is a bit high, 22. And this one, look, 18. And this one is 4. And the last one will be 1. Okay. So this is how you draw your histogram. Remember, for histogram, paksi X dia adalah class boundaries. X-axis. Your x-axis. Your paksi Y will be your frequency. Number of fashion ataupun dia punya frequency. Okay. Frequency yang ni lah. This is all your F. Okay. So, this is your class. This is how you obtain your histogram. Okay. From histogram, you can also obtain your frequency polygon. So frequency polygon is quite easy because you just obtain it by connecting the middle point of each class on the top of the bar in the histogram. You cuma connect all the midpoint, titik tengah daripada bar ni. Kalau tadi you have like this kan? You just connect yang ni, titik tengah dia, this one, tengah-tengah, this one and this one. You sambung. Kalau yang dekat sini, you just ambil lah somewhere dekat sini yang titik tengah. And then you turunkan dekat sini yang titik tengah jugalah. So you just connect all these titik tengah punya points. So this is going to be your frequency polygon. Okay? Okay, then, okay. For example, yang ni kita guna contoh yang tadi. This is your histogram. How you going to obtain your frequency polygon? You ambil titik tengah sini, tengah sini, di sini, sini, and the last one over here lah. So you just connect it. Sambungkan dia. Turun sikit. Sorry, my drawing is not smooth. Okay, then you connect all the line lah. So dia jadi macam ni. So you can have a frequency polygon like this. Okay, the frequency polygon can be either like this with a histogram on it, or you can also have like this, yang tanpa histogram dekat dalam dia. Okay, dua-dua betul. You boleh buat draw straight away from your histogram dekat sini bertindih, ataupun yang macam ni without the histogram pun boleh. So as long as you have connected line. Okay, that is frequency polygon. And no calculation for frequency polygon. Tidak ada pengiraan cara kira. You just connect all the midpoint, titik tengah sahaja. Okay, this is how you're going to obtain your cumulative frequency curve, atau nama pendek dia we known as OGIF. So OGIF is a bit different from histogram and also frequency polygon because OGIF is actually a very smooth curve. Okay, nanti kalau you draw, dia tidak boleh ada kotak-kotak ataupun bar chart macam histogram tadi. You have to use your flexi freehand. Okay, when you draw, you have to use freehand. Smooth curve, a really smooth curve like this. Okay, frequency polygon closely approximates a smooth curve. Dia kata frequency polygon tu lebih kurang lah approximate the smooth curve. Cuma dia ada bucu-bucu kan macam ni. So, a less than cumulative frequency curve. Then we plotted again, ataupun OGIF ni kita panggil sebagai less than cumulative. Nama lain dia less than cumulative frequency curve. So dia ada dua nama, less than cumulative frequency curve or cumulative frequency curve or OGIF. Banyak nama dia. Then OGIF ni we plotted again the upper class boundaries of the corresponding class. So kita guna upper class boundaries. Then the sum of the frequency for classes below that class. Okay, yang ni nanti saya akan tunjuk macam mana. So this is how your OGIF look like lah. Dia guna cumulative frequency untuk y-axis. Ni. Cumulative frequency ni nanti kita akan explain. And dekat bawah ni, dekat x-axis, dia guna class boundaries. So, ada beza lah dengan histogram. Kalau histogram, bawah ni dia guna class apa? Yes, dia guna class boundaries juga. Okay, histogram guna class boundaries. Tapi dekat paksi Y dia guna F, frequency, only frequency. But for OGIF, the y-axis will be cumulative frequency. Okay, for example, over here, you need to draw a cumulative frequency curve ataupun OGIF based on the following frequency distributions. Okay, so now you have this kind of class interval. X greater than 0, less than or equal to 3. Dia bagi dalam bentuk macam ni pula. Equal or greater, less than or equal sign. Bukan dalam bentuk dash-dash kan? So what happen is that okay, sama juga. Yang ni will be your F. Okay. This will be your F lah. This is going to be your F. So what happen from here, you akan ambil class boundaries start from 0 until 3. And then 6, 9, 12. Dia terus ambil kalau macam ni. Kalau yang melibatkan greater than, less than sign ni, you terus ambil straight away daripada sini. 0, 3, 3, 6, 6, 9, 9, 12. Terus ambil macam ni. Itu akan jadi dia punya class boundaries. No need to plus or minus 0.5. Yang you kena plus 0 or plus minus 0.5, the one yang ada macam ni. Yang ada guna dash ni. Kalau yang ada guna dash macam ni, your class interval ada guna dash, untuk cari class boundaries, you kena plus or minus 0.5. Okay. But the one yang guna macam ni, yang guna greater than or less than sign, tidak perlu. You ambil straight away. 0, 3, 6, 9, 12. So, your class width sama jugalah. 3, ada 3 dekat dalam dia. So, to draw a cumulative frequency curve, you need to find the cumulative frequency first. Apa tu cumulative frequency? The cumulative frequency table is shown below. Okay, cumulative frequency. So, kita buat based on class boundaries lah. Kita tambah satu kelas atas dekat sini. Walaupun kita tahu dia start from 0 until 3. So, you tambah satu lah yang less than 0. Less than 0, you have 0. Okay. Less than 3 adalah yang ini. Ada 9. Ada 9. Yang ini extra. This one extra. You kena tambah satu kelas dekat atas. Yang mana cumulative frequency dia 0. And then x less than 6. X less than 6. You have 38. Dari mana datangnya 38 ni? 38 ni, you get it from 9 plus 29. 9 plus 29. That's why you get 38. And then x less than, x less than 9. X less than 9 is 42. So, you tambah lagi lah. 38 plus 42. That's why you get 80. And how do you get 106 over here? 106, 80 plus 26. Okay. So that's why you get 106. Okay, itu yang dimaksudkan dengan cumulative frequency. Frekuensi terkumpul. Maksudnya cumulative frequency maksudnya frekuensi yang terkumpul. You tambahkan dia dengan frekuensi yang kelas sebelumnya. Contoh macam ni kan. You have 9 plus 29. Then 29 plus 42. Then tambah lagi dengan 26. Macam tu. Okay. So this one, the last one will be 106. Kalau you total semua ni, you akan dapat 106. Yang ni, bila you total semua ni, you akan dapat 106. Okay. So, itulah guna di cumulative frequency. Kita guna yang cumulative frequency instead of the frequency. And then you use this one. Yang ni, yang kita dapat tadi. Kita punya class boundaries. Dia guna upper class boundaries. Tengok. Upper class boundaries. Okay. Okay, so for your ogive, the x-axis, you will use your class boundaries previously. Yang ni. Class boundaries 0, 3, 6, 9, 12. So you have 0, 3, 6, 9, 12 as your x-axis, and your y-axis will be your cumulative frequency, this one. Okay, so now let's mark our graph. Okay. Start from 0, class boundary 0, you get 0 lah kan. Class boundary, upper boundary 3, you get 9. This is 9. And 6, you get 38. And then for 9, you get 80. And the last class, which is 12, you get 106. Okay. So then you have to connect all these points freehand. Okay, without using your ruler. Jangan guna pembaris pula. So you have freehand over here, just draw a smooth curve. So this is your ogive. So remember, the only difference for ogive and histogram is that the y-axis over here. Kalau histogram, you only use frequency. But for ogive, you use cumulative frequency. Okay. Yang bawah ni sama, dia just guna upper boundaries. Okay, how about this is a special case when you have unequal class intervals. Kalau you ada class interval yang tidak sama. Kalau yang macam tadi, class interval kita sama 0 until 10, 11 until 20, 21 until 30, sama. But this one, you can see that 0 until 40, dalam ni ada 40 numbers. And suddenly, you have 40 until 50 saja. Dalam ni ada 10. And then you have 50 until 60. This one is also, dalam ni ada 10 numbers. But dekat ujung sekali ni, you have 70 until 100, which consists of 30 numbers, 30 pula. So, dia punya class width ataupun class interval tu tidak sama. Okay, so here you have 40. Here you have 10, 10, 10. And the last one you have 30. So this is a very special case where you have unequal class intervals and also unequal, you will not, meaning that you will not have the same width, class width. Okay, di dalam dia nombor yang terkonsist di dalam dia tidak sama. So consider the data given in the table below. When you have this kind of class interval unequal, dia tidak sama, what you can do is the way the data have been presented make it impossible to draw a histogram with equal class interval. So, kita tidak boleh guna yang ni untuk draw histogram yang macam sebelum ni, that which have equal class interval. So, this is totally cannot. In order to keep the histogram fair, the area of the bar rather than the height must be proportional to the frequency. So on the vertical scale, we plot frequency density instead of frequency. Okay, apa yang jadi adalah you boleh plot histogram, but then untuk yang vertical scale, maksudnya vertical ni yang menegak, you punya paksi Y, instead of using frequency, you kena use frequency density. Itu saja cara dia untuk plot when you have this unequal class interval. So, untuk paksi Y dia tidak boleh guna frequency. You kena guna frequency density. So, what is frequency density? Frequency density is frequency divided by class width. So, macam mana I dapat 0.125 over here? 0.125 over here. Frequency. What is your frequency? Your frequency is 5. 5 divided by class width. My class width ada berapa nombor terkandung dalam ni? Ada 40. So 5 divided by 40, you get 0.125. For this one, 6. The 6 divided by class width. Kita ikut formula ni. You follow this formula over here. 6 divided by, dalam ni ada berapa nombor? Ada 10. 6 divided by 10. That's why you get 0.6. So on so forth. So this is how you get the rest. Okay. So now you have extra column, which is this one. You ada extra column. Okay. So this is going to be your y-axis. Paksi y kamu. It's no longer to be frequency. You're going to use your frequency density. So bila kita draw histogram, you will have like this. 0 until 40. Panjang macam hilang kan dia? 0 until 40. You have berapa tadi? 0.125. You have 0.125. 0.125. And then for this one, you have 0.6. Again, for this one, again, you have berapa tadi? 0.8. This one is 0.4. This one is 0.00. 0.066. Okay. So you can see that the bar over here is not equally the same. Dia tidak sama. Ada yang lebar macam ni, ada yang kurus sikit macam ni, and then ada lagi yang lebar macam ni. So this is actually a histogram, but for unequal class interval. Dia tidak sama kan class interval dia? Ada yang 40, 10, 10 and then all of a sudden this one is 30. So it's not impossible to draw. It's just that the method you're going to use is a bit different. Okay, saya ulang lagi sekali. For histogram, normal histogram, you can use frequency as the x-axis. But for this special case, yang mana dia punya class interval not the same, macam ni kan? Class interval dia tidak sama, you're going to use the frequency density for your y-axis. Okay, so you find it like this. Okay, the cumulative frequency graph can also be drawn with the y-axis as the cumulative frequency and the x-axis as the upper boundary, such as below. So this is the cumulative frequency graph lah. Okay. Dia punya macam ogive lah. Okay.